I have already shared the list of experiments and the manual of first 5 experiments. Have you seen that? Have you gone through it?
Yes, ma'am.
Okay. So according to that, okay, let me first share my screen. So my screen is visible to all of you.
Yes, ma'am.
Okay. So this is your first experiment, that is low pass RC circuit. And I think you might be aware of what is a low pass RC circuit. Have you read it before? Have you heard about the low pass filter?
Yes, ma'am.
Okay. So in this lab, actually we will be using the multi-sim only due to this online classes and all. So I think you all are well acquainted with this multi-sim software, right? You are third year students, right? So you have already worked on multi-sim. Am I correct?
Yes, ma'am. We did our DSC lab on multisim.
Okay. So we will be using that multi-sim only. And today we'll try to complete first 2 experiments, experiment number 1 and 2, both. First experiment is low pass RC circuit and the second experiment is high pass RC circuit, right? In this first experiment, the aim is to design a low pass RC circuit for a given cutoff frequency, and you have to obtain its frequency response. I'll explain you what is the frequency response and what is an low pass RC circuit. Okay. And then you have to observe the response for this square wave when time period is very, very less than RC value, and when time period is equal to RC value, and when time period is very, very greater than RC value. Okay. So for 3 conditions, you have to find out the response for square wave input. Okay. So the aim is clear to all of you. The first aim is to obtain the frequency response of low pass RC circuit with sine wave input. At the input, you have to give the sine wave, and then you have to record the output at the frequency response at the output. All right. Then second aim is to plot the output for the square wave input for 3 conditions. First is T is very, very less than RC, then T is equals to RC, and then T is very, very greater than RC. All right. Any doubt in this?
No,
Any
ma'am.
doubt? Okay. So I would like to show one, just a minute. Okay, my screen is visible. PPT is visible to all of you.
Yes, ma'am.
All right. Hmm. So are you able to see it in full screen now?
Yes, ma'am.
Okay, so first of all, what is a filter? What is a filter? Can anyone tell me what is a filter? A filter is a circuit which passes a certain band of frequencies and it attenuates the other band of frequencies. Okay. So today we will be studying the low pass filter. So a low pass filter, what is it? It actually only passes low frequencies, means it allows a certain band of frequencies, which are the low frequency band, lower band of frequencies, to pass through it, and it attenuates the higher band of frequencies or the signals. Okay. For example, digital filters for something sets of data, right? Some digital filters, they only pass some lower band of frequencies and they stops the higher band of frequencies. Okay, so the band of frequencies which it passes is known as the pass band, and the band of frequencies which the filter stops is known as the stop band. All right. Now this is the circuit of RC filter. We can simply, it is a very simple circuit. You just have to connect resistor at the input terminal and at the output terminal, and then a capacitor will be there at the output terminal. Okay, so uh, the cutoff frequency. What is the cutoff frequency? Cutoff frequency is actually that frequency above which the low pass filter stops passing the signal. Okay, and the frequencies lower than the cutoff frequencies are only allowed to pass through a low pass filter. All right, and it is given by 1 upon 2 pi RC. Okay, R and C are the resistor and capacitor values. All right. So this is all about the low pass RC filter circuit. This is the frequency response. This kind of response you will be getting. This I was telling you, the pass band, you can see the lower frequencies, FC, the frequencies which are less than FC, that is the cutoff frequency of low pass filter. The frequencies lower than this cutoff frequencies are allowed to pass through the low pass filter, and the frequencies which are above this FC, they will be stopped by the filter. All right, and this response you have to check in your experiment. Okay. What are the applications of this low pass filter? In telephone lines, in acoustics, these filters are used. Then in optical filters, and then in radio transmitters also. Okay. Then the second part of your experiment is you have to give a square wave at the input, and then you have to record your response for three conditions. So what happens actually, the RC low pass filter acts as an integrator when a square wave is given at the input. All right. So when a step response or a square wave is given as a input, it integrates that it acts as an integrator. And why it does that? Because the charging and discharging of this capacitor. Okay, once the capacitor charges and then discharges. All right, so that square wave is turned into a triangular wave. All right, so you have to record the response for, and it also depends on the time period, right? The time period constant, that is the RC constant. Okay, so this also you have to verify with your experiment whether it is working as an integrator or not. Now this is the circuit of high sorry, it has been written wrong. It is a high pass filter. So high pass filter can simply be designed by exchanging the values of this resistor and the capacitor in this circuit. Okay, you can see the resistor is now at the output terminal and the capacitor is at the input terminal, right? So now what will be the response? You will get this response. The lower frequencies the frequencies which are lower than cutoff frequency FC, they will be stopped, and the frequencies which are higher than cutoff frequency, they will be allowed to pass through the circuit. All right. Now, actually, what happens? Uh, why it does so? Because suppose we are talking about the high pass filter, right? So what is the reactance of capacitor at high frequencies? At high frequencies, the reactance will be infinite, right? So for infinite reactance, what will happen? This capacitor will act as an open circuit. Okay, so for high pass filter, when the high frequencies are there, high frequency band is there, then this capacitor acts as an open circuit, and whatever input we are giving, that will reflect at the resistor or the output as it is. All right. And for the low frequencies, what happens? The reactance of this capacitor is zero. So it will act as a what? It will act as a short circuit, right? So whatever input you are giving, that will not actually reflect as it is. There will be some drop. Okay. So this will not act as a means it will not allow to pass those frequencies. Okay, there will be drop inside the circuit only. Okay, so the input will not reflect at the output. So this lower frequencies are stopped. Similarly, in the low pass circuit, what happens when the frequencies are high? This capacitor will act as an open circuit, right? So what will happen? What will happen when sorry, for low frequencies, this will act as a what this will for low frequencies, this will act as an open circuit, right? So whatever input you are giving, that will appear at the output terminal. Okay, and for higher frequencies, it will act as a this this it will act as a short circuit. So the output will not be, means this output line which you are seeing, that will be a short circuit. So there will be no drop at this terminal, output terminal. So output will drop to zero for higher frequencies. Okay, so this is all about this experiment. This is the frequency response. So the applications of high pass filter are, they are used in the loudspeakers to reduce the low level noise, and they also eliminate some distortions in the audio applications. Okay. The next thing is these high pass filter will act as a differentiator, which is just opposite of the low pass filter. Okay, when we apply the square wave at the input. Okay, so this is your second experiment. You have to verify this frequency response of high pass filter with sine wave input, and then you have to verify this differentiator application of this high pass filter using the square wave input. All right. So this is all about these today's experiments. Now you can start doing. You already have these manual. Okay, so you can take help of the manual, and you may start doing your experiment. If you have any problem, I am there. You may ask me. Okay, and you have to complete it in during this lab only, and you have to show me the results. And after that, you have to maintain one lab manual for lab notebook actually, and that we will be submitting at the end of this lab. Okay, so maybe in next lab you may show your this lab notebook, but during this lab you have to show me the frequency response of low pass filter and high pass filter. Okay, any doubt, anyone? Any doubt?
Ma'am, the lab copy, can we submit it soft copy, ma'am, like typing on the laptop and submitting it?
Okay, okay, fine, fine, fine.
Yes.
You will submit it a soft copy.
Yes, ma'am. Thank you.
Okay. So you all know, I think I don't need to tell you how to maintain a lab copy. You all are expert in that, I think. Okay. So please submit your lab notebooks before next lab. Okay. Before next Monday. And okay, you can start doing your experiment for today. And if you have any issue in between, you may ask. I'm there only.
Yes, ma'am.
Please try to finish both the experiments today. Be recording the performance of on the daily basis. Okay, and it will contain some marks. So please try to finish both the experiments in this duration only, from 9 to 12, and try to show both the experiments to me, the output of both the experiments. And you are the senior student, so I think you won't suffer much in using this multi-sim software. What frequency you are working on?
Ma'am, I tried the 10 kilohertz given there, but then it is not showing the appropriate output, ma'am. So when I use the
Mhm.
10 hertz, I'm getting the proper sine wave as my answer.
Okay. And others? Anybody else? Are you people sleeping or doing the experiment? Nobody else is responding. Speak up.
Ma'am, I'm getting this as the output, ma'am.
Yeah, you can see the this triangular wave is distorted. The tips are distorted.
Yes, ma'am, little bit it is distorted.
Yeah, yeah. It is because this time constant, this RC is very, very less than time constant.
Yes, ma'am.
Okay. So this is the difference. It will act as an integrator when, means the perfect integrator when your time constant RC is very, very greater than the T time period. Okay.
Yes, ma'am.
So you might be seeing that it is not a perfect triangular wave. There is a charging discharging kind of thing. Means it is rising and then falling. There is a curve kind of thing. If you look at it very carefully, it is not a straight line.
Yes, ma'am. Here we
Are
can
you
see.
getting? Yeah, there
Yes,
is a charging and discharging kind of thing you can see. It is
yes,
because the charging and discharging of the capacitor, right? It is not the straight line, it is a curved line, slightly curved line. It is due to the charging and discharging of the capacitor, right? So it will act as a perfect integrator when this RC is very, very greater than time period T. All
yes,
right. Okay. So you may proceed to the high pass filter experiment.
yes, ma'am.
Anybody else has finished? Harshvardhan, what is your roll number?
Ma'am,
Okay.
BTEC
It is 56.
10007, ma'am. There are two hertz versions. So.
Okay, 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 okay. 10007. Okay. Okay, Harshvardhan, please stop sharing your screen.
Ma'am, is it okay now, ma'am?
Yes, yes, fine.